So I just wanted to run over how to solve this question, which we're looking at similar shapes and how we can solve the values for these pronumerals here, a, b, x, d, c, which can be pretty tricky. There's quite a lot to take in here. And basically we're going to use sort of two facts that we know that if we know if these triangles are similar, then the ratio of the side lengths are going to be equal. So if this is increased from 12 to 36, we can see that that's actually got, if we do 36 over 12 equals 3. So we can see that the bottom side length here has got 3 times longer. Obviously this is not quite drawn to scale, but using our maths we can work that out, because we'd go to 24, we'd go to 36, right? So it's 3 times longer. We can also see that if we were to do up here, we could do 39 divided by 13. We could see that the big one is 3 times as long as the small side length there. So what that tells us to start with, that's that when we increase the size of this triangle and we get it bigger and bigger, that all the side lengths increase by the same amount. So if I was to double the bottom side here, then that means if they're the similar shape, then my hypotenuse here has to double, and this would have to double. We've tripled, so we've got 3 times as big. So as you've increased from this size to this size, it's got 3 times as large, which we want to go back the other way. So we know this big side is 3 times as large as this side. So to work that out, x is just going to equal 15 divided by 3, which is going to equal 5. So that becomes my value for x there. So that's the first thing that I do with similar shapes, is that I know that if any side length is increased by a certain ratio, like got 3 times bigger or twice as big, then every other side will have to have got that big as well if they're the same size triangle, they're the same shaped triangle. Cool, so that's my first one, solving for x equals 5. We might as well leave that written in actually. All right, let's look at our second part to have a bit of a look at. The second fact we're going to use to solve these is the internal angles of a triangle or a quadrilateral all add up to a certain number. So hopefully we know that all my angles in here, if I look at this one, plus this one, they're all going to add up to 180 degrees. And if I look at the angles here, they're all going to add up to 360 degrees. So let's look at, we can solve A then, because we know that what this angle is, we know what this angle is. So if it's all got to add up to 360, so we're at 180, we can solve for that. So A is going to equal, or probably we can write this out a little bit different to start with. Why don't we write 2.26, this one here is 90 degrees plus 90 degrees plus A is all going to equal 180, which I can also write as 180, take all this stuff off, 90, take 22.6 is going to equal 90, 70, 60, 67.4 degrees. Right, so I've solved that one for A. A is 67.4 degrees. Oh, I've written that a little bit dodgy. All right. What's the next thing that we know? Well, we know that this all adds up to 360. We've also got another interesting thing that we can work out here. Sorry, I said there was 2 facts we need. We actually need 3 facts. If I'm looking at these angles here, how much are they going to add up to? Well, a straight angle is 180 degrees. There's my third fact. So I can solve for these. B, if I want to find B, let's do D first. So D plus, this one's 90 degrees again, 90 degrees is going to equal a total of 180 degrees. That means D equals 180, take 90. D is also 90 degrees, which hopefully we can see that if we've got a 90 degree, this angle is also going to be a 90 degree angle. Then we'll jump across here, we'll just use a slightly different color. Now I've got a plus b equals also is going to equal a plus b is going to equal 180 degrees. And I know that a actually equals 67.4 degrees. So 67.4 plus b is going to equal 180, which means that b equals 180. Take away the 67.4, which is going to equal 112.6 degrees. So what have we got? 112.6, and we've got D is equal to 90. We know that this one here is also 90, and that leaves my final angle here, which we can use the area of any quadrilateral is going to equal 360. But we could even do that in a simpler way. We could have done this at the start. We've got an angle here. We've got a big triangle. We know that's 22.6. We know that that's 90. We actually know, because these are similar as well, that C is also going to equal 67.4 degrees. Because in our similar shapes, the angles are also the same as well. So C equals 67.4 degrees.